Hi, welcome back. In this video, we're going to talk about how to solve a quadratic equation using the factoring method. Now, how do I know, first of all, that a polynomial is a quadratic? We're going to want to look at the highest coefficient, right? Sorry, we're going to want to look at the highest exponent that is attached to the coefficient, right? So when you're looking at a function, right, we have polynomials, something like this. We're going to have some sort of equation where the highest degree of the polynomial is a square. And that's how we know we're dealing with a quadratic. Now, our goal is to be able to factor this to be able to solve for x. And I'll do a series of examples. Feel free to pause and do the examples with me as we go through the problems. So let's get started. In order for me to solve these equations through factoring, I must first put all of my equations in standard form, such that ax squared plus bx plus c are all on the same side of the equal symbol. They all have to be on one side of the equation in order for me to introduce this factoring method. Now, I'm going to show you a factoring method that works for me, that works for most cases, but if you prefer to factor using the ACB method or other approaches that you might have learned, feel free to use those. Let's start with this example on the left. Notice how square is the highest exponent that I see in the problem. So I'm going to move everything to the side such that the coefficient of x squared is a positive value. X squared is already positive on the left, so I'm going to move the 6x to the left and the 5 to the left. And since I'm crossing the equal symbol, I'm going to subtract 6x on both sides. Right? I must do the opposite in order for me to have balance in the equation. Now, if I can move the 6x, I can also move the 5. I can do both of these steps at once. Now on the right side, 6x minus 6x gives me 0, and negative 5 plus 5 is also 0. So the equation will equal 0, and on the left, I have x squared minus 11x plus 24. Now that it looks like this form, in standard form, where the highest coefficient is first, or the highest exponent is first, then the x, then the constant, I can now do factoring. Now, in Algebra 1 or in Algebra 2 and other courses, when you're isolating a variable, and I'll do another video about this, whenever you're isolating a variable like this, the goal is to leave the variable by itself by isolating the variable of interest. And you subtract both sides from 5, and by doing so you get x equals 4, right? You're able to isolate the variable and leave x by itself. Well, we cannot do that here because I have an x squared and an x, and these two are not like terms. So I cannot isolate for x squared while isolating for x at the same time. And the only way that I can isolate these two, or separate them, is by finding the factors of this equation. And here's how I like to do it. Now, I do have another video in a different playlist. You can go down to like my Algebra 2 playlist. And in those videos, I can walk you through a lot of examples of this method, where I find the factors of the first column, x times x. And then I find the factors of 24. Now, to get 24, I have 4 times 6, I have 2 times 12, I have 1 times 24, and I have 3 times 8. I want to use a combination of factors such that when I cross multiply here, now I can show you here, and I'm going to use a pencil so that I can erase this. Let's try 4 and 6 as an example. 4 times 6 gives me 24. But when I cross multiply, I get 6 times x is 6x, and 4 times x is 4x. Do these numbers add up to negative 11? They don't, right? Even if I make them both negative, it gives me negative 10. So I know 4 and 6 are not a combination. And I try it some more. The more practice you have with this, the more experience, the faster you're going to be able to identify the correct factors. Well, 2 and 12 give me that. But when I cross multiply, I have 12x and 2x. Can that give me somehow an 11? No again. So with experience and a little bit of practice, you're going to be able to identify that the best one here in this scenario is 3 times 8. When I multiply 3 times 8, I have 8 times x is 8x, and 3 times x is 3x. Now, how can I combine these two in order to get a negative 11? Well, they must both be negative. Negative 8 plus negative 3 gives me negative 11, which means that this value must have come from a negative number, and this negative 3 must have come from up here. Now, is negative 3 times negative 8 still positive 24? You bet. So I'm using this 3-column method in order to double check my work. That the signs are negative, which ones are negative, that they multiply to a positive, all of that stuff. Once I check my work down the middle, my factors will always be on the outside horizontally. Right? I cross multiply to combine like terms, but my factors are sideways, right? X minus 3 and x minus 8. So I was able to rearrange this standard equation into its factored form. Now I'm able to split up these two problems into two actual problems. I'm able to split the two. Here, I'm not able to separate them because they're combined through subtraction and addition, and there's more things going on. But if I find its factors, I could definitely solve for x separately. I can add 3 to both sides, x equals 3, and if I add 8 on both sides, I get x equals 8. Those are my two solutions that would make this equation true. Another way to think about it is that if I plug 3 in here, 3 minus 3 is 0, and 0 times anything will give me 0. Same down here, if I plug in 8, 8 minus 8 is 0, and 0 times anything will still give me 0. So these are the two solutions that create this statement to be true, or the original statement to be true. Feel free to pause it and give this one another go. Now, when you're combining like terms, again, we want the coefficients to be a positive value for x squared. Here we have 5n squared, and here we have 4n squared. If I subtract 4, I would have 5 minus 4, and that's a positive number. If I subtract 5 over here, I have 4 minus 5. Now I have a negative n squared. Again, I want to simplify things by keeping it positive. So I'm going to move everything to the left. I'm going to do the opposite. I'm going to subtract 4n squared. And I'm going to move all the variables over. Minus 6n and plus 14. This allows me to put it in standard form, where it equals 0. 5 minus 4 is 1n squared minus 11n plus 24. Yeah. Now that I have the variables in descending order from highest degree to lowest, I can now break down my columns and practice my method. Now, if you notice, this problem looks quite similar to this one, right? But instead of x squared minus 11x plus 24, I have n squared minus 11n plus 24. So the only thing that would really change is that I'm using n equals now. This is still 3 times 8. I can cross multiply 8n, 3n, and I can get, if I make them both negative, I get negative 11. So this is exactly what we just did, right? N minus 3, n minus 8. It's the exact same problem. All right, let's try something different. Now, notice how here, this problem is already in factored form. If you wanted to multiply all of this, right, you could do FOIL method. You could do the first terms, k squared minus 5k plus 1k minus 5. If you expand it and combine like terms, you would get k squared minus 4k minus 5 equals 0. Since it's in standard form, right, with the x squared being the first term, bx being the second term, and the constant being the last term, I can do my columns to solve. K times k is k squared. 5 times 1 is 5. And when I cross multiply, how can I make this a negative 4k? Well, the only way I can make it a negative is if I do 1 minus 5, which means this value was negative, right? This column allows me to check all the values. These have to add up, right? They have to add up to b, and these are the factors. These are the factors of the function. So I get k minus 5 and k positive 1. When you rearrange this general equation into factor form, I'm able to split them up into two separate problems. Now, why would I go through all of this trouble if I'm already given the problem in factor form? Right? I don't have to do FOIL in all of this process. Whenever the problem is given in factor form, I can just simply set both equal to 0 and solve. So I could have skipped all of this and gone to this step where you move k, you move the 5 and the 1 to the other side. I was just showing you here how that resulted in the same thing. Now notice how here it's not in factor form. This one is, so I can just set them both equal to 0 and solve. Here I have to make it factor form. Now here we can move the 5k squared over, because if I make it a plus 5k, what happens? This turns into a positive k squared. And that's what I want, right? I want this to be positive. If I move the 3 to the other side, I get minus 8k. There's nothing here equals 0. Now, it looks like this, right? But what do I notice? If I want to use the same method with the 3 columns, what do I notice here? We're missing the third term. We're missing this. You're always allowed to add 0 to anything, right? It won't change the value at all. You can multiply or divide anything by 1, or you can add or subtract 0. And if I add the third value, I can now separate this into 2 columns. Sorry, 3 columns. This gives me k times k, and here, 0 times anything is 0. So what should I multiply by so that when I cross multiply, here in the middle, I get negative 8k. Well, I can multiply it by negative 8. Again, anything times 0 is 0. So negative 8 times k is negative k. Negative 8k. Does this give me negative 8? Negative 8 plus 0? You bet. So what are my factors? K plus 0 and k minus 8. Yeah. And now that it's in factor form, like up here, I can split this into 2 problems. K plus 0 equals 0 and k minus 8 equals 0. When is this function going to equal 0? You subtract 0, that doesn't change anything. And if you move the 8 over, it makes it a positive 8. I got my 2 solutions. So if at any point, if you're missing a value, put a 0 for the term that is missing. And you'll be able to factor it and go from there. All right. Last example. I'm going to move the 5 to the other side. I always want the highest exponent first, x, and then the number. And in this case, I do. I get 3r squared minus 16r minus 12. Now that they're all on the same side, I can do my 3 columns and do my factors. Now here, am I able to divide everything by 3 to simplify the problem? No. So, I still follow the method. R times r is r squared, and 3 times 1 is 3. What are the factors of 12, though? 12 can give me 4 times 3, 2 times 6, or 1 times 12. Which of those factors will I use? Well, let's try it out. If I do 4 times 3, when I cross multiply, 4 times 3 is 12, and 3 times r is 3. Does that give me 16? No. Well, then that didn't work. Let's switch the values. Instead of 3 on top, let's put 4 on top. Why does this matter now? Well, now when I cross multiply, 3 times 3 gives me 9, and 4 times 1 is 4. That still doesn't give me 16. Whenever you have another value in front as a coefficient, when you cross multiply, you have to account for the fact that you're multiplying something times your 3. And this is when it definitely takes a little bit of experimenting. So 4 and 3 didn't work in either direction. Let's try 2 and 6. If I do 2 times 6 and I cross multiply, I get 6 times 3 is 18, and 2 times r is 2r. How can I get a negative 16? Well, I can get a negative 16 if I do negative 18 plus 2r, right? Which means if this was negative, it must have come from this 6. And now 2 times negative 6 is definitely negative 12. And negative 18 plus 2 is negative 16. This helps me double check all the combinations are correct. So, what are my factors? The outside, always horizontally. 3r and positive 2, and 1r minus 6. It's important to know that we cross multiply to add them up in the middle, but our factors are always horizontally. If it's a positive, we do plus 2. If it's a negative, we do minus 6. And now in factor form, I can split this into 2 separate problems. It's easier to solve in factored form versus in standard form, because we can't isolate these variables. Here, we can definitely separate them, because as long as one of these is 0, 0 times anything is 0. So I can split them up, and I can solve for 0 separately. So let's move the 2 over, and then divide both by 3. R equals negative 2/3. And if I move the 6 over, I get r equals 6. So, as you practice these, you can have coefficients in the front. If you can divide everything by that number, simplify it. Like this one, right? K squared minus 8 and 0. You can simplify the problem. If you can't, you still use the method, right? Find the factors, cross multiply, and add up in the middle. If it works out, the answers are going to be the factors on the outside. And then when you set them equal to 0, you would solve for your 2 solutions. What do all these 2 solutions mean? It means that no matter what equation you're working with, when is the function equal 0? Another way to think about it is, when does that function have the y value equal 0? We're really finding graphically the x-intercepts, right? This is where it crosses the x-axis, or the x-axis. Now, of course, these are different letters. Like this would be the r-axis, the k, or the, But if we were to convert it to x squares, right? Convert all of these variables to x's. We're really looking for the solutions, right? When does this function equal 0? Or this function equals 0? All right. Don't forget to like and subscribe. And as always, we'll calculate.